Hello! So this is a revision video for IB Chemistry S1.2.3, Mass Spectrometry and Isotopes. This is a revision video, which means only the essential information is covered. For more detailed explanations and for full video lessons, please check the links in the description below and visit chemistrystudent.com. Mass spectrometry is an analytical technique that is used to identify isotopes of an element and determine their relative abundances. This information can then be used to calculate the relative atomic mass of an element. The machine used in mass spectrometry, a mass spectrometer, produces a graph called a mass spectrum, with the x-axis being mass-to-charge ratio and the y-axis relative abundance. Each peak on a graph corresponds to a different isotope of the element. The mz value for each peak tells you the mass number of that isotope, assuming it has a 1+ ion charge. The area or height of the peak tells you how much of it is present in a sample, its relative abundance. To find the relative atomic mass, you calculate a weighted average using the isotopic masses shown on the graph and their relative abundances. For example, chlorine has two peaks in its mass spectra from two isotopes, a peak at MZ35 and a peak at MZ37. This shows us that a sample of chlorine contains two isotopes, chlorine-35 and chlorine-37. The relative abundance of the chlorine-35 isotope is 75% and the relative abundance of the 37 isotope is 25%. Therefore, the relative atomic mass will be 35 times 75 plus 37 times 25 divided by 100, giving 35.5. If you're unsure about that, please revise S1.2.2, Isotopes and Atomic Mass. Exam tip here, really important to remember that technically each peak on a mass spectra is for a charged ion because mass spectrometry actually detects charged ions. So in the chlorine example, the 35Cl is actually detected as a 35Cl plus ion and the 37Cl is detected as a 37Cl plus ion.